Cloud seeding or precipitation enhancement is a technique in weather modification that encourages clouds to yield more rain or snow. It works by dispersing substances, commonly silver iodide, dry ice and increasingly hygroscopic salts, into clouds. These act as nuclei, helping moisture to condense or form ice crystals and ultimately precipitation. Tools include ground-based generators and specially equipped aircraft designed for targeted deployment. Effectiveness remains mixed. A U.S. National Academy of Sciences evaluation and the Wyoming Weather Modification Pilot Project observed only modest gains. Snowpack increases of roughly 3% per season in optimal conditions. The Government Accountability Office in 2024 noted results vary widely depending on location and methodology. 1946, USA, Vincent Schaefer and Irving Langmuir at GE validated the theoretical basis for cloud seeding, leading to the first lab experiments with silver iodide and supercooled clouds. Project Cirrus, 1947, managed by GE, U.S. Army and the Office of Naval Research, this mission seeded a hurricane with dry ice. The storm's unexpected turn prompted public backlash, and subsequent lawsuits that stalled further research for over a decade. Project Storm Fury, 1962-1983, a NOAA-led initiative to weaken hurricanes by airborne silver iodide delivery. Ultimately, scientists concluded most hurricanes don't contain enough supercooled water for seeding to work, and natural storm changes mirrored seeding effects. Operation Popeye, 1967-1972. A covert U.S. Air Force operation to intensify monsoon rains in Vietnam and Laos by cloud seeding, aimed at disrupting enemy supply routes during the Vietnam War. Western states programs, since the 1950s, Idaho, California, Colorado, Utah and others have carried out cloud seeding to boost water resources in snow-dependent regions. Texas. Formalized cloud seeding began during 1950s droughts. By the 1960s-90s, state-funded programs spanned vast areas of West and Central Texas. Today, some 31 million acres remain under active seeding. UAE. Operational since the early 2000s, the Rain Enhancement Program has executed hundreds of missions annually using aircraft, drones and radar. Authorities credit it with up to 30–35% extra rainfall in ideal conditions, though outcomes are context-dependent. China operates perhaps the world's most expansive seeding venture using rockets and ionized devices, focused on drought relief, hail suppression, and ensuring clear skies for events like the 2008 Beijing Olympics. Australia, from 1947 to early 1960s, CSIRO conducted extensive dry ice and silver iodide trials across cumulus regions, South Australia, Queensland, the Snowy Mountains and more, often landing measurable results. Thailand, since 1969, the Royal Rainmaking Project deploys dry ice seeding via aircraft. Hundreds of flights occur annually, though discussion about its effectiveness continues. When cloud seeding became blamed for flooding, and why that's myth. The Lynmouth Flood, UK 1952, a conspiracy-linked Project Cumulus, a UK attempt at cloud seeding between 1949 and 1952, with the catastrophic Lynmouth Flood where 9 inches of rain fell in one day. Meteorologists including Philip Eden strongly refuted this. The storm impacted a broad region, not just seeded clouds. Flooding had deep meteorological origins and local geography played a central role. Dubai flash floods, 2024. When unprecedented rains flooded parts of UAE, public speculation blamed the cloud seeding program. But experts noted cloud seeding only enhances rainfall in existing clouds and cannot create extreme storms. The flooding was attributed instead to systemic factors: climate change, poor infrastructure, and high humidity levels. Central Texas floods, July 2025. After deadly flash floods near Kerrville, Texas, conspiracy theories accused a company, Rainmaker, of triggering the deluge. Yet, Rainmaker's actual seeding occurred on July 2nd, over 100 miles away. Operations were halted when weather data signaled heavy moisture. Meteorologists and officials, including the National Weather Service and Senator Ted Cruz, stressed the floods were caused by remnants of Tropical Storm Barry, not weather modification. Scientific analysis highlights climate change's role. Events like this are becoming 7% wetter on average compared to past conditions. Seeding cannot affect large-scale atmospheric moisture where storms originate. Fact-checkers from CBS News, Snopes, NOAA, AP, and others verified that cloud seeding could not generate storms of that magnitude and is limited in scope. California. Cloud seeding estimated to boost Sierra Nevada snowpack by 310%, providing water to tens of thousands of households annually. Colorado. Programs in mountainous regions can increase storm snowfall by up to 15%, translating to roughly 80,000 acre-feet of water per year, enough for approximately 160,000 households. Utah. Long-running seeding efforts add 13% more water to annual snow, with cost-effective estimates as low as $3 per acre-foot. Nevada, Reno area. Seeding adds enough water to supply approximately 40,000 households per year. Texas, across 6 major programs covering approximately 30 million acres. Seeding adds an estimated 500,000 acre-feet per year, yielding around 4 inches of additional statewide precipitation. Wyoming and Idaho. Active programs exist. Specific figures are limited, but Idaho studies demonstrate detectable, if modest, increases in snow. Cloud seeding. California versus Texas by the numbers. California. Several agencies, including major utilities like the Sacramento Municipal Utility District, have been conducting cloud seeding since the late 1960s. Their efforts are estimated to increase Sierra Nevada snowpack by 310% on average. In the Reno, Nevada side of the Sierra Nevada, winter cloud seeding is estimated to generate enough water to serve about 40,000 households for a year. Texas. As of 2024, 6 weather modification projects in Texas span approximately 30 million acres, about 1/6 of the state. Between 2004 and 2024, Texas seeded around 2,400 clouds, leading to an increase of more than 500,000 acre-feet of water per year, equivalent to roughly 4 inches of additional precipitation across the state. The 2022 State Water Plan project's cloud seeding could provide 5,000 acre-feet per year for irrigation by 2070, which would constitute only about 1% of Texas's total recommended water strategy. Why myths persist, and what experts say. Misinterpretation and outrage after disasters fuel quick conclusions, especially when projects operate out of public view. Cloud seeding's visual appeal, planes dropping chemicals, makes it an easy scapegoat. Yet experts underscore, it only works when moisture is already present. It cannot create clouds, incite storms, or compete with natural weather systems. Distribution of rainfall post-seeding is uneven. Unintended effects remain a concern. Ethical and environmental implications such as silver iodide toxicity and water equity require careful consideration and transparent regulation. Conclusion. From its modest beginnings in the 1940s to modern global programs, cloud seeding remains a scientifically intriguing but controversial intervention. While it may offer incremental help in water-scarce regions, it is not a climate control tool, nor a source of catastrophic precipitation. Floods like those in Linmouth, Dubai, or Texas are best understood through the lens of meteorology and climate science, not conspiracy theories. As demand for water and climate resilience grows, cloud seeding may remain in use, but always tempered by data, transparency, and a clear-eyed understanding of what it can and cannot do.